Everybody successfully download that? It'll work? Okay. So before we get started, can I just ask how many of you has anybody done text mining in Japanese? Okay, good, perfect. That's you're my ideal audience then. So I guess we'll just go ahead and get started. Let people wander in. Thanks for joining me here so early in the morning. Basically, for this workshop, Sean asked us each to teach a technique. And I was thinking about sort of what would be a good technique to teach, and it turns out with text mining, a lot of the good techniques require many, many steps to get there. They require programming and sort of a level of explanation that can't be done efficiently in 90 minutes. And oftentimes what happens is when you teach a technique, an advanced technique, people are like, great, that's amazing, but I don't have any text to work with, or I don't actually have a corpus on which I can, perform this amazing technique. So for this workshop, I decided to keep it quite simple and just sort of outline some of the steps you'd need to first build the corpus of your own, some of the processing steps that you need to do to make that usable, and then I'll introduce you to some online tools that allow you to sort of make kind of initial steps towards text mining and sort of develop an intuition for why you would want to do this at all. And that's sort of my first question. Why do text mining? Do you really need to do text mining? And I ask that question because it can be a major investment if you don't already have kind of a corpus out there available for you to work on. I guess one, for those of you who are, maybe not convinced that you need it, I would say, already, keyword search is a fundamental, core aspect of the work we do. And keyword search is a kind of text mining, right? You're using digital archives to basically pinpoint or explore that archive and locate places of interest. And with the continuing sort of expansion of digital archives, social media, these kinds of things, there's that much more kind of information to explore. And at some point, at least in the case of myself, there was this realization that I work on modern Japanese literature, so there's this great archive of kind of crowdsourced, digitized Japanese literary texts. And I wanted to sort of go beyond the keyword search and sort of think about, well, that has its own uses, but it also has limitations, and we can start to think about what kinds of questions can we answer if we go beyond that. So, when is it useful to go beyond keyword search? Well, to do more sophisticated forms of searching not just for one keyword, but collections of keywords, or searching for patterns of either linguistic patterns over time. So, thinking about how the use of words change over time in a corpus, thinking about how the use of words differ between different subsets of your corpus, between authors, between genres, between time periods. All of these become possible once you can move beyond kind of the basic keyword search. Another question that comes up, at what stage, in the research project is text mining useful? I think it's most useful really in the exploratory stage, when you're beginning a research project, and you need a way to kind of comb through a vast amount or a larger amount of material than you can on your own. It doesn't necessarily have to consume and become the total project. I think that's a sort of a misconception. It can just be one kind of aspect of the work that you do. The other question is, how much time should you invest in learning text mining? I think it really depends on the kinds of questions you want to answer. How, do you really just want to understand the use of a single term, or maybe a set of terms in a collection, or do you want to do more and look for, like, I'll mention some more advanced topics, but if you want to look at kind of topics or themes as they emerge in an archive, if you want to look at sort of the kinds of words that become associated with other words in an archive, semantic change, for example. All of these things are now doable with sort of state-of-the-art tools, but it really depends on the types of questions you want to answer and how those tools fit with those questions. You should definitely ask, is there already something out there that's going to answer my question before you reinvent the wheel? And then it also really, of course, depends, especially for those of us who work not on the modern period, who work on earlier periods, what's out there, what's available to be digitized. Oftentimes that can prove like the very first kind of hurdle if you don't have an archive to work with, and digitization becomes kind of impossible at the scale of one person. I'm just going to skip through here. If you work in literature, how many study literature here? Okay, so history, I assume. Yeah. All right. These are more references for folks in literature. But if you're curious, well, what can it tell us once we go beyond that keyword search? I'll just point you to some of the sort of the recent work that's come out in monograph form. There's a lot of different articles, but these are quite good and representative of what's possible. In Japanese, there's not a lot available yet. If you're interested in examples of how to do this with kind of social media and Twitter, this is a good article for that. A bit of self-promotion. This is an article that I've done that uses text mining, simple techniques to work on a Japanese and a Chinese corpus and to do some comparative work. And then in Japan, there isn't so much happening in the field of literature, but there are linguists who are working on these problems. Kondo Miyuki happens to be a classicist. She works on Genji Monogatari and has done some interesting kind of preliminary work to think about what you can do with text mining in Japanese. But those are just for future reference if you need more motivation to do text mining. So let me get to what we're going to talk about today. The first thing I want to talk about is just some simple steps for creating a digital corpus. How do you get digital texts if you don't have them already? We'll walk through just a quick OCR tutorial. How many of you have done OCR on your own? What programs have you used? Adobe? Okay. Acrobat? Yep. What else? Other programs? What have you used?
Just Adobe.
Okay. So I'm going to just do a quick introduction to a program called Abby Fine Reader, which is I find to be useful for CJK texts. And I didn't expect you guys to have that software, but I'll just show you how easy it is to use, and then we'll move on to thinking about how you organize text and metadata once you have those digitized texts. I'll walk through some simple text mining and also some of the basics to getting to that point. So some of the key pre-processing steps that have to be taken with Japanese texts. I'll introduce you then to some web-based text mining tools, as well as one that I've helped create at Chicago called Aozora Search, which is basically we moved the Aozora Bunko collection into a new search interface, and I'll give you guys a chance to play around with that. And then at the end, we'll go into slightly more complex methods, and I'll introduce some very sort of fundamental concepts in text mining using another web-based tool called Lexos. Okay. And please, jump in at any time. Feel free to interrupt if you have questions. First thing, creating a digital corpus. Basically, in my own work, there's essentially two modes of acquiring text. One, you can search online to see if there are texts, born digital texts you can scrape from the web. But more often than not, particularly with the kinds of materials we work with as scholars, there isn't anything available, and so one has to resort to OCR for printed text. The next thing, and I'll introduce the OCR in a second, after that, then you have to kind of have a simple way for organizing those texts and metadata. What I want to show you today is that it doesn't have to be that complicated. You don't have to know database languages. You can just use an Excel spreadsheet, and as long as you have some good metadata with that, and as long as your files are organized in a kind of a clean, concise way, you can start to do some of these more advanced techniques. I'll also talk about pre-processing steps, things like character encodings, which can be a hassle, particularly with CJK texts, some cleaning and normalization steps that you might need to perform. And then also, this seems to be the key hurdle, tokenization, right? We don't have word spaces in CJ, at least in CJ texts. And so tokenization is kind of this thing that has to be performed in order to give you the word spaces to allow you to do text mining. And so I'll introduce you to some tools for doing that. So this is more just for your reference. We won't do anything like this today, but just to give you a few examples of what you might do if there are online texts available for you to use, particularly with newer like social media archives. Molly Desjardins at Penn and Mark Ravina, who's now at UT Austin, they've written up some great sort of instructional blogs on, first of all, how to scrape certain sites, and then also how to use APIs, which are basically the application program interface that allows you to go and grab data from a particular source. So I'll just point you to those for now. And you should have the slide. You have the slides from that downloaded zip file, so you can follow up with those later. But I want to focus first of all on OCR. So OCR is great when when the materials aren't available for you and you need to create a new collection or add to some existing collection. I found that with the kind of where the technology is at now, it's useful on a small scale, maybe hundreds of texts, because it does require still a lot of labor and personal time investment. Particularly if higher accuracy is necessary. You have to do it in such a way that you at least have to be able to check and correct for errors. So OCR quality varies greatly with the quality of the scans. If it's possible, you want to use a book scanner, right? These are the overhead scanners that will scan from above and thus kind of eliminate some of the features of the book that get in the way of scanning. So they'll eliminate like the curvature of the pages, they'll get rid of the spine in the middle. All of these things make a flatter image and thus make it much easier to do OCR. And typically 400 dpi is recommended. In terms of software options, Abby Fine Reader, the PC version, I found to be quite good. There is a Japanese-made software called eTypist, which has its own kind of idiosyncrasies, but can be more accurate in some cases. It also has the ability to capture the Ruby, the furigana, as it goes, so that can be useful. Tesseract, this is sort of a higher state-of-the-art kind of machine learning OCR engine. I've seen people use it with Japanese, and it's useful when you want to sort of process a bunch of files at once and you don't really need to go and check them. You're okay with kind of the accuracy it gives you. Mark Ravina has also written a kind of a mini guide to how you would use that. That also though requires a little bit more technical knowledge, and you have to use a command line interface, and so that can be a hurdle. Yeah.
Is there a way to change the OCR recognition so that it will not repeat the same mistakes it made repeatedly?
Sure. Yeah. And you can train it basically. And I don't know, I've never done that, but that requires yet another layer of kind of programming knowledge. But
Not these newer OCR tools have that inbuilt.
Tesseract does. Tesseract you can kind of actually train, and I know Donald's been working a lot on the problem of OCR and probably has.
I think Amplify Reader, you can have some kind of training.
Oh, you can? Okay. I haven't used it for that.
Yeah,
but
you have to, I'm not sure 100% is still like that. You have to change you can change when you have the result.
I see.
On the right-hand side, and then you have to change it.
Yep.
And then you have to set a model, and then the program will save those things.
I see. Okay. So you can update that on the fly. Oh, that's great to know. So there's that. So with Amplify Reader, I guess you can do that. Tesseract, is also something where you can do that. But it requires a lot of more data so that it can learn what the mistakes are. Okay. Let me just show you a quick example of Amplify Reader, so you have a sense of what it does. And all these in the slides here, there's a really detailed kind of set of directions, so you can go back to that. I won't go through that. I'll just show you kind of live how we do that. So if you have Amplify Reader installed, and I would recommend the PC version. There is a Mac version, but it doesn't have much functionality. So if you can get access to a PC version, it's all the better. And what it allows you to do is, let's say you have a PDF like this. I'm going to open it in Amplify Reader. It's going to do a little bit of pre-processing. It's sort of, if your pages are skewed, for example, it automatically correct that kind of thing. And it gives you multiple views, so it shows you sort of the document in thumbnail form. Here is where you're going to choose like what sections, what parts of the page you want to analyze. Down here is a zoomed in version, and I'll show you how that's used in just a second. And you'll notice up here at the top is where you can choose your languages. So sometimes it'll open and it'll be in English, and essentially there are two important functions here. One is analyze page. That just is simply, it's going to try to automatically detect what is text, what is not, and try to identify the portions that it wants that it's going to OCR. Now if I do this with English settings, it totally messes up, of course. It has no idea what's going on. It created like an Excel spreadsheet form here, and has identified, basically these color-coded areas, those are the spaces, like they're OCR spaces, where it's going to try to, run the OCR engine. I'm going to set it, once I set it to Japanese, however, and reanalyze the page, it does a much better job. So it knows here exactly, oops. It's basically found the text areas that it's going to render. Now, if you have vertical text like this, the one thing that Abby is not quite good at knowing is, well, which order should I process those in? So you can actually set that. Now, in fact, this box here is from the text that comes prior to this. So I'm just going to remove it because I don't want it to recognize that. And then you can. There's a button here called Reorder. If you click on that and click here, you'll see a little number that's come up. It might be hard to see, is 1 and 2. So now they're in the correct order. And if we do that on the second page, we analyze this page. It's actually done it quite well. It's marked off the top box and the bottom box. And it will probably do those, hopefully in the right order. And you can change the shape of these boxes. So if you click on the select tool right here, you can manipulate the size of these because you don't want to obviously capture this line in the middle. I think the other benefit is let's say you have many more pages to do this on, but if they all look pretty much, if they all have the same format, you can create a template with this page, for example, and you can save this template, and then you can say, run this template on every other page. So if every other page looks the same, it's going to create these 2 boxes on every other page, and that'll save you a ton of time, and it'll just sort of map that all the way down. Then you sort of have to go through and check, make sure that everything is kind of aligned. Let me just make sure the order on this is right. Okay. Once you've done that, then you take the next step, which is to recognize the page. So I'm going to click on that. It does its work. I just recognize the first page. You can recognize all pages, of course. But and then what it does is it spits out the results here. And so you see a lot of blue. This is to indicate passages where Abby says, hey, you better double check this. It actually does it. It's actually pretty excessive. It's more accurate than this would make you think. It does at least help sort of highlight areas that you want to check. So for example, if we look right here where this colon and this caret appear, we know that's probably not right. So let's look what happened. So what it does is, wherever you are in there, down here it shows you exactly where you are on the page. So it should be Subarashi. We should have Ringo again. That didn't work out so well. But what you can do is, we have it actually got it earlier here. So you can just cut and paste. I'm going to put it in here, delete that error. And now, this is ultimately what's going to be spit out. So you're basically just working on this version now. That's going to be your final OCR text. And then you can sort of continue to work through and identify errors. There's also a search and replace feature. So if there's a consistent error and you do Control H, that will allow you to identify all of those and then replace them. Although you want to be careful that it's an error that you want to correct all the way through. Any questions about sort of these steps here? I don't want to go into too much detail because it's hard. You guys don't have this in front of you, but I want to sort of give you the idea that it's very doable. It will take time depending on the quality of the text, but essentially once you've made those corrections, you can then go up and save it as a plain text file. I'm just going to save it as ringo.txt. Let's see, yes. Oh, you can ask it to, I didn't recognize all the pages, so it's just going to go ahead and do that and spit it back out. And now, so I haven't corrected all the errors. Obviously, I'd want to go and do that if I want it, very accurate. But now we've got a text we can work with. This is machine readable. We can start to process this. Okay. So I will come back to that in a second. Okay, we're doing okay on time. All right, so now let me shift gears a little bit to talk about, once you've digitized a bunch of text or acquired a lot of text, what's the next step to do? And I'll just sort of talk about some of the things that I've learned in the years that I've been doing this work. First of all, it's good to have a clean directory structure. And this is just an example. Here I've got all the text, for example, in the corpus I'm working with, and you'll see that I've given them an ID number, right? So one of the things that I think has been useful for me is to not try to encode a lot of information in the file name, but to actually come up with an ID number for your text, and then use that ID number to match the text with various metadata. So here is just the basic Excel spreadsheet with this is actually some of the Aozora text we'll be working with in a moment. But right here on the left side is a work ID or a unique ID number. So every text I have has this ID number, and then it's labeled. The file name has that ID. And then with each of those, I've got the associated metadata. So this is any kind of information I want to have about the text. The title, an author ID, the author information, and text length, for example, and on and on. Any kind of sort of metadata feature that I want to associate with the text. If you have this, you can actually do quite a bit. You don't have to create a database for yourself. You can just use that file, that directory structure I showed you, and an Excel spreadsheet with metadata. And in fact, you'll see that I have an author ID here. That's because I have another spreadsheet where I have information just about my authors. So that becomes useful if I want to have this spreadsheet is based on the document information, but if I want to link that information with my author information, it's good to have sort of the two spreadsheets, and then you can make them talk to one another by saying, okay, let's say if I have information I want to add about these authors, I can essentially use Excel to fill in further metadata. So in that author spreadsheet, I have like all of this information, birth and death date, and I can essentially add that in. I'm not going to go through the steps here, but Excel makes it pretty easy to do that, to make them talk to one another. Questions about this?
Say like author number
Yep.
160, Windows user.
Mm-hmm.
Put that one on your sort of Excel spreadsheet for Uno, so you have a
different
just for Uno.
No, I have a spreadsheet just for the authors.
Or just for the author.
Yeah, so the author spreadsheet would basically, it would have this row on the left,
okay,
and it have all that information, but sometimes I don't want to include all the author information in the title, with the title data or the work data.
So you've got two spreadsheets.
Exactly.
Got it.
Yep.
And the numbers just more accurately matches.
The numbers,
So you can keep them ordered.
yeah, you can keep the order. It's also much use. I found that it's also very useful when you're sort of taking these files and putting them into a different program. If you have Japanese characters in the name, yeah, it will throw up all kinds of errors at you, or it just becomes more efficient to use the numbers, and you can always go back and match if you have that information. Okay, just to why is good metadata important? It's useful because it's a way to understand what's in your corpus. So for example, with this Aozora archive, which is about 18,000 texts now, with metadata, I can start to basically get an understanding of the general shape of the corpus, what's in it. This is a graph, for instance, showing how the works are ranked by their total length. So what you can see is that there's just a very few number of really long works in the corpus. And by the end, most of the works are actually very, very short, including this haiku at the very end. So Aozora, is this large collection of text, but it's actually, its composition is made up of a wide variety of different types of material. So the metadata allows you to start to understand what's in it and the ways you might want to start dividing it up to answer a particular research question. Good, for example, the Aozora data also comes with library codes, the National Diet Library codes. So you can actually use that and get an understanding of what types of material are in it. It turns out it's a lot of fiction, but the next largest category is criticism. So there's a ton of material in here that's just sort of literary criticism. Then we have poetry, and then on down the line to a whole variety of stuff. But this tells you, for one, if I'm just interested in fiction, well, then I can actually cut the Aozora collection in half, and I just want to look at this material, for example, to do some analysis. Okay, let me talk a little bit about the pre-processing stuff. Just a few sort of key things to keep in mind. So if you've OCR'd a text, you won't have to worry about this. But let's say you get a text off the web. Oftentimes, that text is going to contain a lot of other kinds of information. Tags, for example, that help with the web formatting, various metadata or information about the text above. You don't really want that as part of your analysis. So if you've scraped material off the web, oftentimes you have to. This will require some programming language, but you have to kind of clean it up, right? So you could remove those tags using what's called a regular expressions or regex expressions. That's a whole kind of sub-language to itself. I don't have time to talk about that, but it's good to know that word, regex. It basically allows you to search for, let's say, find me any instance of a word that appears between two brackets. You can use regex to say, find me anything like that, and then tell it, and then you say, I want to delete those instances. So very easily, with one line of code, you can clean up most of these tags and get rid of that. You also want to, usually there's like paratext at the top or bottom of a page. You want to filter that out. With the Japanese case, there's also some kind of normalization that can be useful. For example, between different styles of orthography. There's the older style, Q-kana, also older characters, the Q-kanji. If you have texts that have one set, some of those texts have the older characters and some are using the newer characters, obviously you don't want those to be recognized as different words. You want them to be normalized. So you want to essentially kind of replace the older with the newer, so that when you're doing comparison, you're actually comparing the same things. Yeah.
That seems like a not a trivial thing to do. And when you have, like, you can't just replace foo with oo.
Right. So with the Q-kana is harder, but with the Q-kanji, there's actually a designated kind of list of about 200 of those, and that I've used that to basically do a search and replace on the documents.
It's complicated if you try and walk on programming to do something like Q-kana.
Yeah.
You need a larger index of words.
Exactly. Yeah, but I haven't found that to be too much of a problem in doing comparison and. But if you had, basically it just requires, you'd have to find a list, look at your corpus and say, there are these words that are in Q-kana and I want to change them to here, and then you can do kind of a search and replace, But obviously it's hard to be 100% accurate with that. The other thing you wanted that's really important is tokenization or segmentation. And I'd say this is probably one of the largest hurdles to doing text mining in Japanese. There are some good programs out there to do it, though. The one that I've used is called MeCab, or Mekabu, I think in Japanese. That's how they say it. And the reason this is good is you can use it in Python or R. And also the Institute for Linguistics has developed a set of dictionaries that allows you to use this but specialized, or to tweak it so that it's useful for historical writing, so classical Japanese, but also modern forms. And so using these in combination actually does a pretty good job of getting you a cleanly tokenized text. Obviously, the question of what is a word, or how do you define, what is a word, how do you mark a word, it's a highly sort of problematic question, and oftentimes there's going to be a lot of disagreement about what constitutes a word. But this is sort of what we have now for state of the art. In one of their examples, they show how you can use it to parse the phrase sumo momo momo no uchi, right, which is this tongue twister in Japanese, but they show it accurately parses that phrase. So sumo mo is a noun, it says. Mo is a particle. Momo is a noun. Mo is another particle, and so on and so forth. And what I've done here is I've taken that text we saw earlier and I've basically put an asterisk where MeCab put a space. So you just could sort of see how it's parsing things out. Now the real problem here is that to do this, you don't want to do this one text at a time. And so to do a number of texts, or to do batch process, requires R or Python. So there is, at least right now, there is that kind of basic programming that's required. Mark Ravina has written another useful blog to show you how you can do that with the R programming language. I'm going to show you, though, there is one tool that's been developed by the National Institute for Linguistics called Web Chamame. Here's the URL if you want to go to it. And what this does is it allows you to input any text you have, non-tokenized text, and then choose from any one of the dictionaries that they have. So you can see here's Gendaigo Hanashi Kotoba, so spoken modern Japanese. We have Kindai Bungo, right? So kind of late 19th century Japanese, and then even Chusei, also Chuko Wabun, Jodai, in case you're doing the Manyoshu. So a really kind of broad range of options there. Let me just show you quickly how it works. So if we take just a portion of this text, I'm going to delete that space. If we have that in there, and I'm just going to treat it as Gendaigo, you can also select all of the information that you'd like it to spit out. So it contains a vast amount of information, including the part of speech tag, the basic sort of lemma form or the stemmed form of the word, pronunciation, all kinds of things that might be useful to analysis. And when you say, analyze that, essentially what it's done is it's broken down all of those words into the tokens. What it decides are the word tokens. Gives you sort of their various different forms, how it's read, for example, part of speech, and so on and so forth. Now, if you're using R or Python, you can actually access all of this information as you process the text. So let's say you wanted not only to tokenize, but you wanted to get part of speech tags, you can do that with those programs. So it's really convenient once you have that set up. Unfortunately, if you don't, basically what you end up with is this a spreadsheet with the tokens, and then you have to kind of go and process that. So for example, if I go back here, you see you can actually spit it out as not just an HTML, but as a CSV file or an Excel file. So if you do that and then open it up in, let's say, Google Sheets, for example, because if you open it up in Excel, it's just going to give you mojibake, garbage characters. If you open it up in Google Sheets, you'll be able to see what I just showed you in a spreadsheet form. But then you have, how do you then transfer that into a raw text file? It becomes, right now, there's just no kind of easy way or quick way to do that. But at the very least, I wanted to introduce this tool to say that, there is this powerful tool out there, and this gives you an example of what you can do with tokenization. I know Donald is working on his site, Donald Sturgeon, who works with Chinese languages. He has a site called Text Tools. And he is, I think, currently working to implement this MeCab Unidic process into his site so that you could just upload a text and it will spit back out the tokenized version. So that, hopefully, if that works out, there would be a much easier way to do this. Okay, let's get back to text mining. So what I want to do now, let's say you have a corpus, what do you do with it? How can you make use of it? I want to show you first I'll start with some simple keyword search methods and show you this search interface that I built for the Aozora Bunko corpus, and then we'll get into some more advanced tools. Okay, so keyword search, it's an everyday research tool, but it's also very imprecise. It gives you all or nothing. I compare it to a vacuum cleaner. It just sucks up everything, but it erases the relation of text to context. And essentially, it doesn't really give you a useful way to start to think about how you might search for extended patterns, and to do that at various scales. So just to give you a sense of some of the tools that are out there, there is a tool called Voyant. How many have used Voyant? Some of you are familiar with it. So this is great if you want to do analysis on a small number of texts. You could just go to this website, and I don't think I'll have time to talk to sort of get into this, but what you'll come to is this page. You can upload a text or paste in a text, and what it's going to do is generate a lot of statistics for you about word usage in that text. So I just cut and paste what I had just done for the tokenization. It's pretty handy if you have a document or even a series of documents. It's going to give you kind of information about what are the most frequent words. It gives you a little window into showing you how those words are used in context. It gives you some time series, or certain, not time series, but like over the course of the document, how often are certain words used. So it can be. It's a useful tool if you're working at a small scale. But what I'm going to focus on is actually two tools. This Aozora search tool, which is basically allows you to go through the Aozora corpus and do some searching that goes beyond the keyword search. So what it does is it allows you to find words in specific contexts. It allows you to compare those contexts, and this Basically, it uses the metadata that I showed you earlier, about metadata about author, about genre, and whatnot. It allows you to move between scales, between the distant and the close. Allows you to filter on a lot of the metadata features and gives you some limited kind of statistical measures. Once I've introduced that, we'll get into the more sophisticated analysis with Lexos. But what I'd like you to do now is actually go to the website that's listed here at the top. So let's see. Oh wait, you guys need I'll let you put the URL in first. Does everybody have that page? Okay. So you should have something that looks like this. This is the landing page for the site. And I'll introduce you to the basic functions of the search engine. So I'm going to just insert let's start with a keyword for self, jibun in Japanese. If you put in that keyword and click on the little magnifying glass, it's going to go through I think there's roughly 15,000 texts in this version of the collection. Basically, it's going to go through all of those and tell you, just like a search engine would, how many hits there are total, about 141,000, and it's going to show you each of those. All right. So here we're confronted kind of with a mass of information. What do we do with that? One of the things that this search interface sort of builds in is the ability to split or filter by various metadata fields. So if we look over here to this browse by facet section, if we click on any one of these, it will tell us, for example, which authors, in documents by which authors does this term appear most frequently. So here it gives us the absolute frequency. So Miyamoto Yuriko has the most hits for this term, followed by Natsume Soseki, Yoshikawa Eiji, and so on. Some of these names will be familiar to those of you who work in literature. One of the things that's interesting here is that absolute frequency, that's just sort of the raw number of hits, but it can be deceptive. So why is Miyamoto Yuriko on the top?
Really long work.
Long works, and somebody has gone and digitized almost her whole entire collection and put it on Aozora Bunko. So it's not that she's just more, obsessed with Jibun. It's because she has more information, more documents on the. Right. So in that case, to get a more accurate sense, you want to click on this relative frequency, and that gives you basically a measure, based on the number of documents the authors have in the collection, who's actually using it the most, kind of per page. And here we get, a very different kind of selection, a different ranking. So it's just, if you just click right here next to it, yep. So that's one thing you can do. You can also browse by, for example, well, actually I'm going to do, if you browse, let's browse by author. As soon as you click on any one of those authors, you're actually like narrowing the search. So I'm going to click on Natsume Soseki. And what you'll see at the top of the page is that now you're searching for the term jibun, but only in works by Soseki. It's basically, you're starting to zero in on whatever kind of subset of text you want to look at. So here we have, now we're down to about 7,600 references. We can then filter again on something like title, for instance. And I'll do relative frequency. So here now you can start to see, like within this author's corpus, at least what's available in Aozora, which works tend to use that term excessively. So you can switch between those two terms. I'm going to focus on, I'm going to filter down even further. So now I'm looking at just instances of jibun in the work Sorekara. And you'll see that with this corpus, I've actually kept the furigana, or the ruby markings in the text, so you can see these are what's in the original Aozora documents. So there's, oh yeah.
What does the relative frequency number mean?
So that's just it's basically a calculation of, how many times jibun is found in the text over the total number of words in the
It
text.
doesn't match. The number resulting that is resulting doesn't match just the frequency of the number.
Right. It's a proportion. Yeah. So it's just number of that search term over total number of words.
And then they count it back.
And then it's just that calculation. Yeah. So it's like 10 over 100, for example. If jibun appears 10 times out of a total number of 100 words, it's 10 over 100, and then that's the figure.
That's not the figure. I mean, that's exactly what I mean.
Oh, but that
The figure is just 10 over 100. That figure is something else. I just curious how to derive that figure.
no, it is the division. So I guess.
One example is 8 out of 534 words, or 2,030 words in 142,585 words, and then that gives you that ratio.
Yeah, it's just it's the ratio. Maybe I'm not understanding your.
I don't know ratio is right as an thing, but just maybe, but it's just.
It's out of what?
It's out of the total number of words, if I remember right, in every work by that author. Or it depends on what you're filtering. If you're doing it by title or by author, it will change that amount. So from here, I'll just show you some of the other things that you can do. This next tab is called Quick, or Keyword in Context. If you click on that and then rerun the search by clicking the magnifying glass, it just gives you a different representation of the search we were already doing. So this allows you, it basically lines up all the instances. And let's say you wanted to do some sort of syntactic or grammatical analysis of how the word is used. This is a better representation to start to do that. And in fact, you can actually sort the results by terms on the left or right. So maybe you have a hunch about words that come before or after. I'm going to sort. If you click on this, there's a couple of options here. I'll click on words to the left and resort it. And so now, basically, you have it sorted by anything that appears on the left. So first, it's sort of sorted. It's sorted by commas and periods. But as we move down, you'll see. or actually it's not using, it's probably ignoring the commas and periods, but it's sorting by, the Japanese word orders. So ga is everything that starts with that, every instance where ga precedes jibun is now lined up in one spot. So this just becomes a different way to sort of search through your results. Collocation is a tool that's basically goes through and identifies within each instance, for every instance of jibun, it looks at the sentence in which it appears and tabulates, counts all the words that appear in the same sentence, and then gives you a kind of a ranked order of how that shows up. Now, if you know Sorekara, you will know why these two characters appear. And you'll also realize, well, the tokenization didn't do a good job here. So this is Daisuke, the name of a character in the story. The tokenization has actually split that and not recognized it as a name. But if you look further down, you'll see some other things that might be of interest here. Actually, I was trying to find. I'm going to click on, so you can actually click on any one of these words. I'm going to click on the word for to think, omo, here. And once you do that, you've sort of, this is an example of how you can do multiple keyword search. So now we're looking for instances where these two words appear in the same sentence in this particular work. What it's going to give to you now is going to highlight those words and show you where they appear together. And you can actually set the range of how close you want them to be. So here we've got the words, quite a distance apart. It's a fairly long sentence, but with some advanced, with some of the more advanced search options. So over to the right here, there's a button called Show Search Options. You can actually set that amount, like how close you want those words to be. And so let's say you want to show instances where they appear within two words from one another, or three words or whatnot. You can do that here. I want to sort of, I won't show you that now, but just to sort of give you a sense of that functionality. I'm actually going to sort of switch and look up jibun and kokoro. And I'm going to now do that in all of the works. And just to show you the sort of the final tab here, this is the time series analysis. This will actually go through the corpus, and for all the texts where there is date of first publication information, will give you a sense of where those two, in what time period those two words appear together in the same sentence. Here again, you want to be careful about absolute and relative frequency. It's always better to do relative frequency with time, just because of the if you, for example, have a lot of texts that in your corpus that appear in a particular decade, that's gonna be more representative of your corpus overall. So an absolute frequency will maybe just be telling you that you have a lot of documents in the period 1910 to 1920. Relative frequency gives you sort of the frequency based on the number of documents for that 10-year period. And then you can actually use these squares here to zoom in and, for example, search just instances within that time period. All right, so this would allow you to do, again, I think one of the advantages of this kind of platform is that you can actually move and subset and filter based on these different metadata categories and thereby kind of zero in on a set of text that might be interesting for your research question. Why don't we, let's just take 5 minutes. If you guys want to play around with this, I'll give you some time to do that, and I can answer some questions by moving around the room. I'll also put up here just some examples of some of the more advanced searching that you can do. Words, here's an example of searching for 2 keywords. You can do, let's say if you have variants that you want to look for, you can look for this word or this word. Right? So sometimes we have the older representation, so you want to look for both instances. There's some other sort of functionality here, but I just want to give you guys a little bit of time to play around with that, and then we'll move to the last phase of the workshop. Yeah.
I have a question not related to this, but I see that the database itself has full text for almost everything.
Yes.
So I am curious about the copyright.
So that's a great question. Aozora Bunko only includes out-of-copyright texts. It's a crowdsourced, it's like Project Gutenberg. It's a crowdsourced site, and they check the texts. So they're based on the author death date in Japan. And so everything on that site is out of copyright, and thus we can present it here without any problems. Yeah.
So this is basically a question I have about something like Happy Trust, right?
Mm-hmm.
Huge collection of data that's
Yeah.
all kind of hidden, or a lot of it's
Yeah.
hidden because of copyright.
Right.
Is it possible to do some mining or something like that?
It is, and they've created some tools that allow you to do that, but it's what it requires is you to basically log on to their machine and to do all of your analysis on a machine that they have running, kind of a virtual machine that they have running at their site, and it's pretty well locked down. So it's great that you can do it. There's a lot of steps that are required, and the problem is you have to really know what you're looking for, and you have to have essentially any analysis that you're running on it, that all has to kind of work remotely. So it doesn't allow for a lot of kind of tuning, fine tuning. You just sort of give it to them, they run it, and then they just give you back whatever the results are. You don't get to actually see the underlying text. Yeah. But they do have, materials that are that you can get access to the full scan, and they do have a lot of that material has been OCR'd. But if you look, you'll see that the OCR on the Japanese documents can be pretty bad, so it makes it kind of not useful. But yeah, so we also have collections through this website or through this interface that we've set up that are not out of copyright. Essentially, we've password protected them. So we make them available to kind of individual researchers, but yeah, it's a...
Is it possible to open to the public without full text, but still can do search?
Yeah. Yeah, so the group that's sort of helped with designing this has done this for some of their collections. So it basically will just give you like a snippet view, but won't allow you access to the full text. And in fact, we're working with... Yeah, something like that. We're working with the Shanghai Library, actually, we have some of their Republican journals, materials from the Republican Journals collection, digitized and uploaded into an interface just like this one, and we're sort of figuring out how we can make that accessible without revealing the full text. Yeah. Other questions before I? So, oh yeah.
So if you get results here, are there ways of downloading some of the?
Yes. So you can actually there's a button there. It's not as convenient as we'd like it to be. This is something the developers are still working on. But over in the right-hand corner, there's this export results button. The problem so it exports it to what's called a JSON file, and then you have to figure out how to work with that. And so it's not like a CSV or anything, but that's what we have. That's what's available right now. Yeah. I know this collection won't be as interesting for those of you who don't work on modern Japanese or modern Japan or modern Japanese literature, but yeah. But I think even as a teaching tool, if you're teaching literary texts, particularly in Japanese, this is a really kind of a useful way to understand sort of the language usage for particular terms, to see how different authors use that term, and how it may be, how its valence, its meaning may change across authors and across sort of the time windows that's available to look at here. So in the time I have remaining, I want to show you guys this final tool. So something like Philologic, which is the name of this Aozora search, that's the name of the interface here. You know, it's good for discovery. It goes a little bit beyond the keyword search. It may allow you to develop some hypotheses about word usage and where particular combinations of words are most prevalent in certain authors or certain time periods. It helps you identify, passages to close read, and it may help you develop some hunches about lexical patterns, syntactical patterns, or word use. So what comes after that? So just to speak in very general terms, as you move beyond the keyword search, things that become possible are sort of identifying some semantic patterns as they occur around particular keywords. The collocation feature of Aozora search is sort of a step to that. So looking at what kinds of words appear together consistently. Identifying those changes in more sort of statistically kind of rigorous ways over time or by genre. And then identifying differences in patterns relative to different subsets of your collection, whether it be author or genre or time period. So some of the ways that are now being used to do that, to get to these sort of more difficult questions, the one I'm going to talk about today is called basically the vector space model, which sounds more complicated than it is, but it's basically a way to compare documents based on their word usage. And I'll dig into that in just a second. We have ways now to classify documents based on the features they use. So machine learning is essentially this tool that we have now to identify a set of features, grammatical or lexical, syntactical features, and say, well, in what ways do those they tend to be associated with one set of texts versus another. Machine learning helps you kind of basically classify documents based on some model, some set of features you've created. Topic modeling is another term you may have heard of, but that allows you to analyze sort of clusters of co-occurring words across a large collection, and thus to kind of discover. Some people would call it discourse. Some people are more hesitant to make that shift, but essentially sort of topics or themes as they're distributed, as they're spread across your collection. So this vector space model, just to give you a little bit of intuition about what's behind it, essentially it relies on this model of text as bags of words. It's the bag of word model. So you think of a bag and you've got your words in there. Every document is a bag of words, or whatever unit of analysis you're looking at. And these words have different weights based on their frequency, right? So one document will be defined based on the range of words it uses and in what frequency. And the idea is that the combination of these weights in each bag that you have provides a kind of a measure of similarity, of how much these documents are related to one another based on the words that they use. And that these combinations can then provide signals of things like authorship, so style, authorial style, genre, or even time period. So a vector space model, the vector space representation, to put it in really simple terms, let's just take a document or a set of documents, like 5 documents, and then break them down into these columns, which show you the frequency of each word in those documents. So these become the vectors. So we have 5 vectors here. Document 1 is defined by the use of complexity, algorithm, and entropy used in that frequency. Document 2 uses traffic and network. Document 3 uses, complexity, traffic, and network, and so on. This is essentially a kind of a representation of that bag of words model. So now every document is just a set of numbers. But here the numbers just indicate raw frequency, but there are different ways to give weight to the words. So raw frequency is one way, but as we've kind of already encountered, it can be problematic. For example, if document 1 is 1,000 words long and document 2 is only 100 words long, raw frequency is naturally just going to be higher in document 1 because it's longer. So you need a way to kind of correct for that, and there, relative frequency or normalized frequency is the way to do that. So it would just be the number of times over the total number of words. So that's a kind of a proportional frequency. Another way to weight it is this term TF-IDF, which means term frequency inverse document frequency. It sounds quite complicated, but it's this measure that was developed in the 1970s. And what it does is it says, okay, I want to give more weight to terms that only appear in a few of my documents and are not spread across all documents. So to make that more concrete, complexity here appears in 4 of the 5 documents. So if you're comparing those documents, complexity is actually not all that meaningful as a way to identify differences because it appears in every document. So in fact, maybe traffic and network are actually a little bit more significant because they appear in these 2 documents, and thus they are more kind of representative, or they're better ways to define what's unique about those documents. So TF-IDF basically is a way to weight, to give a number to these words that will raise the value of those and downweight the value of something like complexity. And this is important. I want to introduce this because it's going to come up in the tool that I'll show you guys. But let's just say that there are different ways to think about how you give a weight to the word. And the vector space model is essentially just using kind of linear algebra and this idea that those vectors, those strings of numbers, are actually, they point off into this n-dimensional space Here we only have 3 dimensions because that's all we can visualize, but if you had 1,000 words, you'd have 1,000 dimensions. And let's say every document, here it has sentence, but every document is an arrow pointing off into this space, and then you can use, essentially math to identify how far apart those vectors are. Here's kind of a cartoonish representation. But let's say you had just two words, for example, and this is one document, this is another document. They're pointing in different directions because this document uses, this word 10 times, but this word only 4 times. And then this uses this word 8 times, but only this word 3 times, whatever. Essentially, the math that you can use are to either measure the distance between the very tips of the vectors, or you can take a measurement that measures the angle between them. And so the further away, the larger that angle, the more distant or the more dissimilar those documents are, and vice versa. This is just to give you the kind of sense of the basic, what's happening, the basic intuition behind this model. And now we're going to go, I'm going to show you how you can basically take some tokenized text, put it into this tool called Lexos, and start to do some of that, this very basic kind of vector analysis. So if you could go to that website here, lexos.wheatoncollege.edu. You should see this page. So you can drag individual files here. I'm going to do that. Well, actually, I'll have you all do that. In the downloaded zip folder that I had you guys grab, there's a folder called Sample Corpus. So here, what I've given you are 20 texts from the Awazora collection that I've cleaned and tokenized. And in the workshop materials folder, there's also a metadata spreadsheet that gives you metadata about what they are. But if we let's take 204, for example, and I'm going to just drag it over. Lexos basically uploads it. So it should be there now. And what you can then do is, if you go to this section called Manage, you'll see a representation of the text. You can also then give it a name, document name. You can give it a class, which is to say like some category. And you basically sort of could do that if you had a small corpus of text. You could essentially upload them one by one, give them the name and the class information if you have that, and then start an analysis. Now, because we don't have time to do that here, I've actually done that for you. So what I want you to do is actually click Reset, and that's going to clean everything off. And what Lexos allows you to do is, if you've done that, if you've sort of gone through and uploaded a bunch of text, you can save it as a Lexos file. So this file here called workspace.lexos represents work I've already done to input information. If we drag this over, this may take a little bit longer to load. Hopefully it works for everyone. If we go to Manage Now, you'll see that we actually have 20 texts there, where I've inputted the title and also a genre. I have 2 genres here. One is popular fiction, one is I-novel or confessional fiction. Did that show up for everybody? Okay, good, it worked. All right. So you can start to, I'm just going to introduce you to a few of the features of this. Up here, you'll see there's a prepare tab and then a visualize one. We can do a basic word cloud, for example. And this is going to give us the frequency, the representation of the overall frequency. As you'll see, what comes up most are particles, right? Ta, no, ni, wo. And you can sort of, as you run the mouse over those, it'll show you what the actual count is of each of those. So it turns out, these kinds of particles and other what are called function words, grammatical function words, are not always so helpful when you're comparing documents. And so what I'm going to show you is how to get rid of them. So if we go to prepare and scrub, I'm going to uncheck these boxes here. And you'll see in the middle this thing for stop or keep words. So stop words are usually referred to as a way to call these grammatical function words. And here you can actually take a list, which I've prepared for you. If we go to upload, let's see. And if you find that folder where things are stored, you'll see this stopword._jp.txt file. And this just contains a comma-separated list of stop words. If I click on that, and I'm going to call these stop words, click on stop, and if you say apply, what it's going to do is it's going to go through and basically take those words out for you. It's taking a little while. Can we all click on the same time? Oh. Yep. Manage. Yeah. Oh, it's not doing anything?
So it just gives me an error. So I have uploaded it and it gave me this error. So I'm wondering what I. Okay, so I browse this.
Yep.
Open. Sometimes actually I have to reload.
Oh, it didn't actually.
But sometimes, usually it will come up there.
Okay.
There
Oh,
it goes.
there it goes. Now go to manage.
Oh, and it worked.
It worked. Okay. So what you'll see, you'll see that the texts have changed here, and then if we go to visualize again, we should see a different set of words. All right. So now we've sort of stripped away a lot of those functional words, those particles, and we can see words that are more related to content. We're running out of time, so I'm just going to show you two more key features, which are maybe useful. So if we go to analyze here, we can get some basic statistics on the collection. In particular, so it's going to take, this comes up, but it actually, I'm not sure, it actually does work. But there's this red thing. It just takes a little bit while because it's going through and calculating kind of the frequency. But what this top area shows you is kind of the length of your documents and how that's distributed. We can see most of our documents are of this length, but we have a few very long texts. It seems to be quite slow, maybe because we're all using it at once. All right, I'm not going to wait for that. But essentially what would happen here is it would show you every document and then show you kind of the number of words in each document and also give you a measure for the vocabulary richness or density of that document. Oh, here we go. So it gives you the number of single or unique terms, gives you the total terms, and gives you a sense of the vocabulary density. And if you click on the help button over on the right, it'll give you an explanation of what all these mean. This density basically is a measure. The lower it is, the less rich or diverse the vocabulary is in the document. The higher it is means the more unique words are used relative to the total number of words. The other functions I wanted to introduce, and there are notes in the PowerPoint, but dendrogram and k-means, these are essentially ways that you can start to think about to do this vector space analysis. So it's going to just automatically generate a dendrogram, which is a tree showing how the similarity, it's going to take the similarity measures, and then the works that are grouped together, those are works that are more similar based on the words that they use. And you can see that you can change both the types of measures, the weight measures that you use. You can also change the number of words that you use. So maybe you only want to look at the top 100 or maybe the top 500 terms. That's going to change your results slightly.
But you can use this to sort of guess that maybe two works may have been written by the same person.
You could use it for that, yeah, for authorship attribution. All of these works happen, I chose them specifically because they're by different authors, because I'm more interested in genre. But if you did 10 works by one author and 10 works by another author, maybe threw in a work that was not by an author you don't know, for example, this would be a way to kind of discover where.
More likely to be
Yeah, exactly. Yep. So this is one kind of analysis you can do. I think the other very useful analysis here is this top words analysis. Because I've inserted that class information, so I have two genres, popular and then I-novel, which is a type of confessional self-focused fiction. If I click on each class to other classes, and I'm just going to use the top, let's say 500 terms. Oops. And I say generate. What it's going to give me is a measure for which words are more significantly correlated with one set of one class over another. So, for example, it's comparing class I-novel compared to class popular. So what this means, what it means is that the more positive a value is, the more it's associated with I-novels. So, for example, the words kare, he, and then the more negative is, the more associated it is with popular novels, with the other genre. So the comma turns out to be more significant in popular novels. Now that could be interesting, but it probably tells us we need to remove punctuation, and so you would go back to your stop word list and add those things. But for instance, other things like boku, right? I appears more in the I novels. That's a good sign. Tells us something. I'm trying to go down. She, for example, also more I novels. Jibun.
Katana appears more often in popular works.
Yes, it does. I was trying to find some more popular works here, but yeah. But anyway, as you can sort of play around with all of these different, the words that you decide to remove, the number of words you decide to compare. All of these will sort of shift the results that you have. But hopefully, this gives you a kind of at least a beginning sense of how you might use this vector space model to start to think about how to compare and explore differences in a large collection of texts. In the rest of the PowerPoint, I give you a few more resources that you might go to do further analysis. I'll just leave that there for your exploration. And then also some more kind of online tutorials that will take you a little bit further with some of the topics I've introduced today. Sorry for going over time, but I hope you guys have at least learned some of the basics for how to get started with Japanese text mining, and thank you for listening.